Welcome to another Simply Diagnostics video. Thanks for watching.
Today we're going to be going through the basics of common rail diesels. Today we're working on my van. There's a fair bit wrong with it, but nothing with the high pressure system. So we're just going to run through the fundamentals, show you the basic components, basic testing methods, and specifically on this vehicle we're looking at the Denso system. It's a 2007 2.2 Puma engine 4HU Citroen Relay with the Denso fuel system, and we'll run you through it. Today we're going to be using the DCU 220 coupled with the Picoscope 4425. We've got the G standard, simple multimeter, connections for the Pico, channel A, which is the blue channel, that'll be most of the generic testing on the 12 volt circuits. We've got channel B, the red channel, which I've got coupled to a 20:1 attenuator, and channel C is the amps clamp, the inductive amps clamp, and that's connected up to the Pico TA018 6020 current clamp, inductive current clamp, and that's all we're going to be using. So the layout of this vehicle is as follows. We've got the fuel filter in the corner behind the near side headlamp. We've got the injection pump, which I think is the HP3 Denso injection pump. Got basically here we've got the fuel rail control solenoid, the high pressure control solenoid, commonly known as a suction valve on this, or SCV. We've got the fuel inlet, the black pipe here, and then we've got the high pressure outlet pipe, the steel pipe that you can see there, that's feeding the rail, and it comes up, feeds the rail here. Then we've got the common rail. We've got the fuel pressure spill pipe fuel pressure relief valve for the rail. On the other end of the rail we've got the fuel rail pressure sensor. You can see I've already got it back probed. You can see that I've already got it back probed. I've got a blue on the 5 volt feed, the reference voltage. I've got a yellow on the signal wire, and I've got the green on the sensor ground. Then we've got four steel pipes going off to each of our injectors. The leak off pipes on the back of it. The black plastic pipe there, that's the leak off pipe, and obviously the electrical connector to each injector. And then feeding the whole system, we've got a pump in the tank which is supplying about half a bar rail pressure, half a bar low side pressure to the fuel filter, which supplies the high pressure pump, which in turn is converted then into high pressure fuel for the rail and the injectors. So the first thing that we've got to do before we do anything with the scope and take any measurements is do a plausibility check on our ground. You see there, I've got it connected to a ground on the chassis, so I'm on a chassis ground here connected, and then it's connected over onto the battery there. So that's all I'm doing is a plausibility check now. We can see we've got battery voltage, so now I can start my measurements. Right, so the most critical sensor in the fuel system has got to be the fuel rail pressure sensor. It's mounted directly, normally it's mounted directly on the end of the fuel rail. They're normally a 3-wire sensor. That would be a 5 volt reference, a ground, and a signal wire, signal return back to the ECU. So if you've got any issues at all with rail pressure codes, anything like that, it's always a good idea to make sure that the rail pressure sensor's getting everything it needs before you check anything else. So remember that the blue is the 5-volt reference, the green is the signal ground, sensor ground, and the yellow is the signal return back to the ECU. So what we're going to do here, we're going to kill two birds with one stone. We're going to check the sensor ground and the sensor 5-volt feed at the same time. So I've got the scope ground connected directly into the sensor ground and the blue channel A going into the 5-volt feed. Right, so scope set up. We're going to go on to a 10-volt scale here in the top left. We've got channel A set to ×1 probe, 10 volts. We've got 1 second screen time, 2 million samples, and I've just set a simple rising edge trigger just to catch the key on of the scope. Set the scope running and we'll see what we capture. So you can see the key on there went straight up to 5 volts. If we do away with the trigger, we'll see that it's continuously running at 5 volts. So we've got a continual 5 volts there running. So that tells us now that the 5-volt supply to the sensor is okay. It also tells us that the sensor ground is okay. So that's 2 wires checked off using 1 test. The next thing we're going to look at is the signal. So to check the signal, you can see now I've moved channel A over onto the yellow wire, which is pin 2. I've kept my scope ground on the signal on the sensor ground. So back over to the scope. Right, so for testing the signal wire, you can see there I've dropped it down to a 5-volt range, 200 milliseconds time on the screen, and my trigger's still just, we'll put my trigger on 2 volts. Okay, we'll start the scope running, turn the key on and see what happens. So what you can see here, we zoom in. Actually, I can do better than that for you. I can do better than that using the zoom function on the Pico, which is this little window here at the top that I'm hovering on. Select the zoom tool. Okay, so what we can actually see is the self-check for the sensor that's performed on key on. Sorry about all the background noise, it's like filming in a zoo. Right, so you can see here the baseline 0 volts. Baseline of 0 volts. This is the key on, and it's going up to about 3.5 volts. Key on as a self-test, and then it drops down. We'll get a measurement for you of that. It drops down then to about 1 volt. So with the Denso system, you're looking for 1 volt at key on. If you're looking with a standard multimeter, you wouldn't capture that with a standard multimeter. Just pull a ruler across here from the left, and another ruler from the left. You can see that self-test is 4 milliseconds, give or take. so you wouldn't, it's highly unlikely you would catch that with a multimeter. So basically what you're looking for is when you turn the key on with the Denso system, you're looking at 1 volt at key on. We get rid of the trigger. You see there, we've got roughly 1 volt with key on. Okay, and what I'll do now, I'll just start the engine and you can see what's going on with the rail sensor as we start it. So we pull the ruler down at idle. We're looking at about 1.3 volts at idle. A bit more time on the screen, and then what I'll do, I'll just rev the engine up now. Stop the scope. Let's have a look at that waveform. Right, so again, if we zoom in using the zoom feature, we'll just look at this period of time here, which is the wide open throttle. You can see we got maximum voltage. So this is something you could do with a multimeter. You don't necessarily have to have a scope. So at wide open throttle, not running, about 3.5, 3.6 volts. And these dips that you can see are actually the segments of the pump raising the pressure, and in combination with the injectors firing, dropping the pressure. And what we're looking at this period of time from there, when I first commanded wide open throttle, to it actually achieving maximum pressure, is 712 milliseconds. So that's less than a second. So that indicates really good health for the high pressure system. No cause for concerns there whatsoever. That's the rail pressure sensor covered. We'll move on now and look at the injectors. Right, so the connections for the tester are as follows. We've got our scope grounds, the common scope ground going to body earth, chassis earth. We've got channel B, it's connected into one of the wires on the injector. Channel C, we've got the amps clamp going onto the other wire of the injector, and channel A, we've still got going onto our rail pressure sensor. For scope setup, I've gone for 200 milliseconds. We'll bang that up to a million samples. Channel A, I've got on 5 volts DC. Channel B, I've got a 20-to-1 attenuator to 400 volts. And channel C, I've got the 60 amp current clamp and 60 amp mode. And we'll drop that down, let's say we drop that down to 20 amps. I've got a repeat trigger set up on channel C, so that's the current flow for the injector. And what I'm going to do now, we'll start the scope running, and I'll start the engine. see immediately we've got a lot of hash. You can also see that channel C is overrange, so I'm just going to go up to the next setting. Set that up a bit. Alright. So what we're looking at there is channel B is the electrical part of it, and channel C is the actual current. So you can see, let's stop the scope. Turn the engine off. You can see that what you can actually see there is the injector's actually being fired. It's actually doing work between here and here, but it's actually being fired as well every time here. Now what this is back EMF from the other injectors, so it's only actually firing in this one event. And we zoom in on that, we can have a look at it. So straight away this signal tells us that we're not dealing with piezo injectors, we're dealing with a solenoid type injector. Even though it's a Denso system, it's actually a solenoid type injector and not a piezo injector. So peak voltage is about 157 volts. Oops. And peak current is about 20 amps. And you can see what's happening each time it's firing. It's actually firing twice. So you've got the shorter primary injection, which gets the burn going, gets the combustion going, and then you get your main injection period here, which gives the bulk of the big bang. So there we go, known good current versus voltage on a 2.2 Puma in the injector. Another quick test we can do on the injectors is literally just to ohms test them. So all I've got there, I've got a couple of pico breakout leads, and I'm going to connect them up to my scope. The first thing we need to do, obviously again, is a plausibility check. So I'm going to do, turn my meter on. See that there, two leads together, 0 ohms, leads apart, open circuit, open OL mega ohms. And all I'm going to do now, just connect the two jumper leads. So we've got the two jumper leads connected there, onto the scope screen, onto the meter screen. You can see a good injector, about half an ohm, something like that. It doesn't matter which way around the leads are. I'll swap the leads around quickly. You'll get the same measurement, half an ohm. And basically all you're checking there, you're just checking the integrity of the windings in the injector. Alright, so the next component we're going to look at is the fuel pressure control valve suction control valve, SCV, whatever you want to call it. It's a 2-wire actuator. You can see a back probe there on both wires. I've got enough channels, so basically I've got channel A on one wire, channel B on the other wire, and then also down here in the bowels you can see I've actually got my scope. You can me current clamp. You can see just the red end of it there. I'm actually clamped onto one of those orange wires, just to see what current's going through the valve. And scope setup, we've got channel A on 12 to 20 volts, channel B on 20 volts, and channel C we've got on a 5 amp scale for inductive amp clamp, 60 amp clamp, 20 amp mode. I've got it free running, I've not got any triggers, so we'll start the vehicle up and see what happens. So you can see channel A, we're on low voltage there, so that's going to be our ground circuit, I would have thought. We can knock that down a bit. What's that pulling? That's pulling about just over a volt. We've got the valve control and the red channel, which is obviously battery voltage, and then our current, we're pulling about 4 amps, something like that. Well, let's see what, we'll just put a bit longer time base on the screen, and I'll just give it a little rev and we'll see what happens to the current. Right, so if we look at this in a little bit more detail, we want about 20 milliseconds. We'll put a trigger up, a repeat trigger on B. Simple rising edge trigger on B just to steady it down. We'll see what happens when we rev it up. Go back a couple of screens now. What we can do, we just do time. So we go right back to the beginning. So it's frame 1. Not a massive difference at all. No difference in duty. So let's have a look at it again. It's starting. Now we'll rev it up, let it come back down to idle and turn it off. So you can quite clearly see where we did the wide open throttle. You can see the, I don't know whether, well you can see it quite clearly, the current drops. It actually does less work, the valve does less work to increase the pressure. Duty cycle there. About 31, it's about, duty cycle's about 31% at wide open throttle. Current 2.7 amps. As compared to, if we go back to the beginning of the frame, when we weren't commanding it open. Duty cycle about 40%, and the current 3.7 amps. So you can actually see what it's actually using. It's working harder to reduce the fuel and works easier to increase the fuel. So basically, if you were to, I don't know, if you were to I would imagine if you were to disconnect it, it'd probably go to maximum fuel pressure and not like mad. So to summarise on this this opening video in the Common Rail series, we've been looking at the Denso system today. We will go into it in more depth. One of the primary things you've got to remember when you're working on common rails is the fact that you've got to be really clean before you open any fuel lines or anything like that. Pay very particular attention to the voltages, both of the injectors, the high pressure side of the fuel, and like I say, the most important thing is no contamination whatsoever of the fuel system. A lot of the components are in the pressure system. When you open, like the high pressure pipes, if you take a high pressure pipe off, the manufacturers recommend that you replace the high pressure pipes. They're normally single use only. Most of the trade doesn't do that, but that's the advice that they give. That system that I've been working on today, the Denso, I'll now have to go and reprogram my fuel pump, because having it unplugged, we'll have set a DTC, and I'll probably have to go and do a fuel pump learn on that again. Solenoid injectors, they're okay, but the big thing I would say with any injector is do not unplug any injector with key on. If you're doing any plugging in or unplugging of any component on a common rail system, always make sure the ignition's off and the system is powered down before you unplug anything, before you plug it back in. Failure to do that could result in very serious and very costly damage to the components. When we're looking at a common rail system, we'll always have a low pressure fuel supply, be it from a pump module, be it from the high pressure pump dragging the fuel up. Normally if there's an in-tank pump, low pressure pump, you will not see a bulb anywhere near the fuel, a primary bulb anywhere near the fuel filter. If there's a primary bulb, it's a very good indication that there's no low pressure pump. So you've got a fuel supply from your tank to your filter, then from your filter to your high pressure pump. From your high pressure pump then it gets ramped up and goes to the rail, and then it's at a usable pressure for the injectors. On the spill side of the injector, which we'll cover later, the reason we didn't cover it in this video is the leak off pipes on this vehicle. Once you take them off, it's a devil to get them to reseal. Normally end up putting new leak off pipes on. So I've not done it on my van because I've got to go work in it tomorrow morning. But we'll do leak off and spill testing on another vehicle that's actually got a fault. So you've got, like I say, you've got the high pressure supply, and then you've also got a leak off or spill side to the injectors. The fuel actually comes back out and is returned back to the filter or the tank. That acts as a lubricant, as a coolant for the injectors and the high pressure system, which again is really important that the fuel filters are changed, that you're not using strip diesel, and always try and use premium fuel if you can. Like I say, it's just the opening video of the series. I've deliberately left massive gaps in this video to promote discussion. If you jump over onto our Facebook page, it's simply Diagnostics YouTube, that's the group. Come and jump over there and let's get a discussion started about the video with questions that you want answered, the gaps filled in that are there. And like I say, I've left those gaps deliberately. I've left some things a little bit vague to promote discussion, to promote comments. If there's any particular thing that you enjoyed in the video, make sure to give us a thumbs up and leave a comment why. And if you didn't enjoy the video, give us a thumbs down. But again, please leave a comment why. It's no good giving us a thumbs down and then not saying why you didn't like it. So I really would appreciate that. And look out for the next video in the series. We're going to be doing one on Bosch injection, one on Delphi injection, and then we're going to be doing a more in-depth look at the Denso system. But like I say, I hope you've enjoyed this intro into the world of common rail diesels, and we'll see you in the next video. Thanks for watching.
And thanks for watching the video. If you liked it, don't forget to leave us a thumbs up, hit that subscribe button. If you didn't like it, give us a thumbs down, put in the comment section below and let's get a conversation started. We've also got ways you can support the channel now if you look in the links below. We've got Patreon, buymeacoffee.com and a direct PayPal link. Thanks for watching and thanks for supporting the channel. You're awesome.